Hello, hi friends. So today we will be discussing this concept of containers, Kubernetes, and pods in telecom clouds. So as you can see here that this is hardware. So these are two mainly structures. One is this one, and second one is this one. In the first one, we can see that this is VM based. You can say infrastructure kind of thing. Virtual machine is there. So as I had already told that it has hardware, then it has operating host operating system, then it has hypervisor, then it has the guest operating system, then on above that libraries, and above that it has applications, so which are called virtual machines, 1 2 and 3 like this. And this is the containerized services. So how the containerized services looks like, that it has hardware the same as this virtual machine system has. It also has hardware. Then it has host OS as well, like this. It has host OS. Then it has here container engine. It doesn't has this hypervisor. It has container engine. Above that, it does not have this guest OS like this. It has direct libraries and then application, and these are called container 1 2 and 3 like this. So in this system, if we see that the difference between the this VM system and the containerized system is that the container has one layer less. It doesn't have this hypervisor, or you can say it doesn't have the this one guest operating system. So the processing becomes faster in this containerized this ecosystem. So this is one advantage of containerization, and it is the better form of this cloudification virtualization, containerized. So this is the advantage, that it has one layer less if we count here. So and broadly see that this container system share the operating system. They share the operating system, and they share the operating system. Here is separate for every application, guest OS, guest OS, guest OS, but here the operating system is same. And they share hardware. This virtual machine systems shares hardware infrastructure, but they share operating system as well. So these are the broad difference between this virtual machine and containerization system. So what is a container? Container basically is a you can say a pre-compiled package, and in this package it has executable file libraries and the files for starting the containerized services. So it's a complete package in itself, that is called container. Right now just understand this, that it has everything whatever is required to run this. So this is called container. It has executable file libraries and whatever the file is required to execute these. This is called container. So broadly the type of containers are that two types are there: system containers and application container. So as the name is suggesting, the system containers are running many application, like a node. A node is I'll tell you later what is a node. So the system container, as the name is suggesting, running many applications. For example, node, that is called system container. And any the minute unit of container which is dedicated to a particular application. There could be many application in a node. Okay, a node can have many application, and the container which is dedicated for a particular application, that is called application container. Now what is the next thing comes is container runtime technology. Now what is this container runtime technologies? When you saw this diagram, this container engine, this is called container runtime technology. Okay, so if you see this container runtime technology hosts applications, application 1 2 3. So how it is done, let's see. So in this is called container runtime technology. So which runs on container, okay, which run container on them, sorry, which run container on them, that is container runtime technology. For example, Docker, Containerd, and CRIO. These two are example of container engine, you can say, or container runtime service, this technology. So if you see how, what is the model of this, so there you see in this is container runtime technology, or you can say this is container engine as well, and it could be either this one or this one, it could be anyone. These are just two examples of this. So container engine here, what is container engine? This one is container engine. Okay, so this is container runtime technology. So yeah, so here this is Kubernetes. So Kubernetes is runs on this container runtime technology. You can say that it is used, this container engine is used to host Kubernetes services, and the interface between this Kubernetes and this is called container runtime interface. So this is an open interface. So what is Kubernetes? Kubernetes is required to orchestrate and manage containers on container runtime services. So in the above picture you saw that there are here are containers, like sorry, I can make it here. Okay. Here there are containers. So containers are hosted on container runtime engine, and to orchestrate and manage these containers, this Kubernetes is required. K8 or Kubernetes is required to orchestrate and manage these containers. So if we see the background of this Kubernetes, so that is generally abbreviated as K8. It is, we can say in short term, we can call it as K8. So K8 was developed by Google in 2014 in Go programming language, right? So this K8 can deploy, manage, interconnect, upgrade, and scale containers. This K8 or Kubernetes we can say can deploy, manage, interconnect, upgrade, and scale containers. So broadly, if you see the architecture of Kubernetes, this is the master, this is one master component of Kubernetes architecture. These are nodes, right? These are nodes. Suppose these are 3 nodes on Kubernetes: node 1, node 2, node 3. Under these nodes there are pods. This is a unit wise segregation of this. So if you see the architecture of Kubernetes, this is master. This master has controller, scheduler, and API server. So these controller and scheduler controls and schedules the work in these nodes. So these nodes are kind of you can say the calculators or working machines on which these pods are hosted. And this is external workstation command Kubernetes, through which we can manage Kubernetes, or we can give commands. This is how it is controlled. These are external workstation for controlling this Kubernetes. So these 3 main parts comes in the architecture of Kubernetes. So if you see the Kubernetes model or the object model of K8, so here is the cluster. You can understand the group of working nodes. You can say the group of working nodes, like this is a cluster. You can say this is a cluster. Okay, so we can the group of many working nodes or working machines can be called as cluster. Then the in hierarchy, if you see, the next unit comes not hierarchy, sorry, from top to bottom. We are coming from the biggest identity towards the smallest one. So then the next thing is node. Node is this one. These are nodes. 3 nodes are there, like in this. Then the smaller unit of node is pod. So pod are hosted under nodes. You see here, these are pods. Pods are hosted under nodes. And the pod, the architecture of pod, if you see, pod may have one or more containers in itself. It may have one or more container. It could be container. It can be having one container, two container, or three containers. So container is small, is the smallest unit. Smallest unit means in a pod. In a pod. If the K8 object model, if you see, so these are the top to bottom, like from biggest one to smallest one. Now comes another term, that is microservices. So microservices is a concept for decomposing functionalities or services for scalable, deployable, and independent functional pieces. So how we can understand that? Suppose earlier few monolithic applications were there, monolithic applications. So in those applications, what used to happen, that all the services used to be combined in a pack, in a kind of a bundle pack, you can say. So all the services used to work with each other. So if we have to upgrade our services, we have to upgrade the complete package. If we have to scale one service, we have to scale all the services. So that was monolithic application kind of structure was there. But now the microservices, what microservices has done, that it has segregated all the small services, so that if we have to do anything in this service, then we can upgrade, scale, or whatever we want to do, and we don't have to touch these services. So this is the benefit of microservices. All the services has been segregated. So if you see, microservices is a pattern, and containers is a implementation, the way of implementation to deploy those microservices. After that, if we for example, if we see few terms that are generally used in telecom clouds, that is PNF, that is physical network function, that is referred to as the legacy network. For the example of these are classic BTS and RU, whatever the hardware part is deployed there, and that is called physical network function. That VNF comes, that is virtual network function. So virtual network function can be built on VM and as Kubernetes pod as well. Like okay, virtual functions can be, as I showed you in the starting diagrams. Let me take you there. So these VNF, this could be a VNF, and this can also be a VNF. So it all depends upon that. It could be on virtual machine and on containerized systems as well. That is virtual network function. Then this is called CNF. That CNF is containerized network function. So this is explicitly used for those functions which are hosted or which are explicitly based on containers. Examples are VDU, VCU. So the functions which are based on containerized systems are containerized network function. Or you can say the VNFs which are explicitly based on containers can be called as CNF. So these are few brief about the containers, Kubernetes, and pods that is generally used in telecoms. So fine, so that's it for today, and we will meet for our next session soon with new something succession of this session. Okay, then